What if I told you that in 1996, when the entire automotive world was convinced that dual overhead cams were the future, Chevrolet built an engine that made everyone question everything they thought they knew about performance? An engine so controversial that it split the engineering community right down the middle. This is the story of the LT4, spelled with the number 4, not the letter, and how 330 horsepower from ancient pushrod technology shocked an industry obsessed with complexity. And picture this. It's the mid-1990s. Ford's just dropped their modular 4.6-liter with dual overhead cams and 4 valves per cylinder. Toyota's running variable valve timing. BMW's Vano system is the talk of every engineering conference. Magazine editors are writing obituaries for the pushrod V8, calling it a dinosaur waiting for the meteor to hit. And then Chevrolet walks into the room with what looks like the same basic engine design they'd been running since 1955 and says, "Rears, watch this." And the 1996 Chevrolet LT4 350 cubic inch V8 wasn't supposed to exist. By every metric the industry was using to measure progress, it was backwards. 2 valves per cylinder when everyone else had 4. A single camshaft in the block when competitors were mounting dual cams in the heads. Pushrods, actual mechanical pushrods, actuating the valves like this was still 1965. But here's where it gets interesting. This supposedly outdated engine was about to teach the entire industry a lesson about the difference between complexity and effectiveness. To understand why the LT4 mattered, we need to travel back to the early 1990s. General Motors was hemorrhaging market share. Japanese manufacturers were eating their lunch with more sophisticated engines. Ford was modernizing aggressively. European manufacturers were pushing technology that made American V8s look agricultural by comparison. The automotive press was brutal. Every review mentioned how primitive the small block Chevy was compared to the competition's overhead cam designs. GM's board was asking uncomfortable questions. Something had to be done. The small block Chevy had been the backbone of GM performance since 1955. Same basic architecture for 4 decades. Sure, they'd made incremental improvements, electronic fuel injection here, aluminum heads there, but the fundamental design hadn't changed. 1 cam in the block, push rods operating rocker arms, 2 valves per cylinder. While that consistency had benefits, mechanics nationwide knew how to work on them. Parts were everywhere. The aftermarket was massive. It also meant GM was trying to compete in the 1990s with 1950s technology. And enter the LT1 in 1992. This was GM's first serious attempt at modernizing the small block for the new decade. Reverse flow cooling that sent coolant to the heads first, allowing higher compression without detonation. Computer-controlled ignition, multi-port fuel injection. The LT1 made 300 horsepower in the Corvette, which was respectable for 1992. But by 1996, respectable wasn't enough. The competition was moving too fast. Ford's 4.6 was getting stronger. The Japanese were pushing 100 horsepower per liter from naturally aspirated engines. Ferrari's F355 was making 375 horsepower from the same displacement as the small block Chevy. GM needed something special, and the LT4 program started with a simple but ambitious goal: extract maximum performance from the pushrod architecture without adding complexity that would compromise reliability or serviceability. The engineering team, led by John Juriga, wasn't trying to reinvent the wheel. They were trying to perfect it. Every component would be optimized. Every restriction would be addressed. Every inefficiency would be eliminated. But, and this was crucial, the basic architecture would remain unchanged. This would be evolution, not revolution. The foundation was the same 350 cubic inch displacement that Chevrolet had been using since 1970. That's 5.7 liters for those keeping score. Bore stayed at 4 inches. Stroke remained 3.48 inches. The block was still cast iron, though they'd switched to a stronger formulation with higher nickel content. But that's where the similarities to previous small blocks ended. Because what the LT4 team did with that familiar foundation was extraordinary. All right, Janetta, let's start with the heads. The LT4's aluminum heads flowed 200 cubic feet per minute on the intake side at 28 inches of water. The exhaust ports moved 160 CFM. Compare that to the LT1's 175 CFM intake and 135 CFM exhaust. That's a 14% increase in intake flow and 18% on the exhaust side. How? Larger valves, 2.0-inch intakes versus 1.94 and 1.55-inch exhausts versus 1.50. But it wasn't just about size. The ports were reshaped using computational fluid dynamics, something that was still cutting-edge technology in the mid-1990s. The valve angles were optimized. The combustion chambers were redesigned. Every sharp edge that could cause turbulence was radiused. Every restriction was eliminated. And on in the camshaft was where things got really interesting. The LT4 used a hydraulic roller cam with 0.476-inch lift on both intake and exhaust. Duration was 286 degrees on the intake, 285 on the exhaust. That's a hot street cam by any standard, but what made it special was the lobe design. GM's engineers used what they called an arched asymmetric acceleration profile. The cam opened the valves aggressively, but closed them gently. This reduced valve train stress while maximizing the time the valves were open at useful lift. The overlap, that period when both intake and exhaust valves are open, was carefully calibrated to create a scavenging effect that actually pulled fresh air into the cylinders. Now here's where the LT4 got clever. The rocker arms were roller-tipped units with a 1.6.1 ratio, same as the LT1, but the LT4 versions were made from a different alloy that was both lighter and stronger. The pushrods were thicker, 5/16-inch versus 9-32-inch, to handle the increased valve spring pressure. Those valve springs were another story entirely. Dual springs with dampers, rated for 120 pounds on the seat and 325 pounds open. That's serious pressure for a street engine. Most overhead cam engines of the era used single springs with half that pressure. In compression ratio jumped to 10.81 from the LT1's 10.51. That might not sound like much, but combined with the better breathing, it made a significant difference. The pistons were hyper-eutectic units with a slight dome to achieve that compression. The coating on the skirts reduced friction. The ring pack was optimized for minimal drag. Even the wrist pins were upgraded to a stronger alloy. One tidbit: the intake manifold was a work of art disguised as a chunk of aluminum. The runners were tuned for peak torque at 4,800 RPM. The plenum volume was increased by 15% over the LT1. The throttle body grew from 48 mm to 52 mm. Every transition was smooth. Every runner was matched. This wasn't just about flowing more air. It was about controlling exactly how that air moved into the cylinders. But wait, there's more. The LT4 got a different water pump with redesigned impeller blades that moved 30% more coolant. Why does that matter? Because keeping an engine cool is what allows you to run 10.8.1 compression on pump gas without detonation. The oil pump was upgraded too, with higher volume to keep those heavily loaded bearings happy. Even the harmonic balancer was different, lighter to reduce rotating mass, but perfectly balanced to eliminate vibration. The result of all this optimization: 330 horsepower at 5,800 RPM and 340 pound-feet of torque at 4,500 RPM. Now, I know what you're thinking. 330 horsepower doesn't sound that impressive today when a Camry makes 300, but context is everything. This was 1996. The BMW M3 of that era made 240 horsepower from its inline-six. The Porsche 911 Carrera made 282. The Acura NSX, Honda's technological tour de force with dual overhead cams, VTEC, and titanium connecting rods, made 290 horsepower. The LT4 was playing in serious company, and those were gross numbers. The real story was in the power delivery. The LT4 made 90% of its peak torque from 2,400 RPM to 5,600 RPM. That's a 3,200 RPM window of massive torque. Try getting that from an overhead cam 4-cylinder. The power curve was so flat you could use it as a level. No peaky power band that fell on its face below 4,000 RPM. No waiting for VTEC to kick in, just instant crushing torque from idle to redline. Let's talk about where GM put this engine, because that's part of what makes the LT4 legendary. The primary application was the 1996 Corvette Grand Sport. Only 1,000 Grand Sports were built, 810 coupes and 190 convertibles. Admiral blue paint with white racing stripes and red hash marks on the left front fender, ZR1 width body panels, special wheels, and under the hood, the LT4. This was GM's way of celebrating the end of the C4 Corvette generation, and they didn't hold back. And on the Grand Sport, with the 6-speed manual, was a weapon. 0 to 60 in 4.7 seconds, quarter mile in 13.2 seconds at 107 miles per hour, top speed of 168 miles per hour. Those numbers might not shock you today, but in 1996, that was supercar territory. The Ferrari F355 did the quarter in 13.3 seconds. The Porsche 911 Turbo ran 13.4. The LT4 powered Grand Sport was hanging with cars that cost 3 times as much. But the Grand Sport wasn't the only car to get the LT4. Chevrolet also dropped it in the 1997 Camaro SLP SS and the SLP Pontiac Firehawk. These were limited production models built by Street Legal Performance, GM's semi-official tuning partner. The Camaro SS in particular became an instant classic. With the LT4 and a 6-speed manual, it was the fastest Camaro since the original 1969 Z28. The Firehawk was essentially the same car with Pontiac styling and equally brutal. And here's what made the LT4 special beyond just the numbers. This engine proved that there was still life in the pushrod design. While everyone else was adding complexity, overhead cams, 4 valves per cylinder, variable valve timing, Chevrolet showed that careful optimization of a simple design could match or beat the complex alternatives. The LT4 was lighter than any dual overhead cam V8. It was more compact, allowing better weight distribution. It was easier to service. Any competent mechanic could work on it. And it was infinitely tunable. Nenchent, that tunability is crucial to understanding the LT4's impact. With just headers and a proper tune, these engines would make 400 horsepower. Add a more aggressive cam, and you're looking at 450. The aftermarket went crazy for the LT4. Every major performance company developed parts for it. Heads, cams, intakes, supercharger kits. The options were endless. The overhead cam engines from Ford and the imports. Good luck finding aftermarket support. And even if you did, the complexity meant modifications were expensive and risky. Ince and the LT4 also proved something important about American performance philosophy. While the rest of the world was chasing specific output, horsepower per liter, GM focused on what actually mattered, real-world performance. Sure, Honda's S2000 would eventually make 120 horsepower per liter, but it needed to spin to 9,000 RPM to do it and made no torque below 6,000. The LT4 made its power everywhere, all the time, with no drama. It was performance you could use every day, not just when you were bouncing off the rev limiter. Nanswen. The engine's internals told a story of intelligent engineering over flashy technology. The crankshaft was nodular iron, not forged steel. Why? Because nodular iron has better damping characteristics, reducing harmonics. It was also cheaper to manufacture, keeping costs down. The connecting rods were powdered metal units, incredibly strong but again, cost-effective to produce. This wasn't about cutting corners. It was about choosing the right material for the application. The cooling system deserves special mention. The LT1 had introduced reverse flow cooling, where coolant went to the heads first, then the block. The LT4 refined this further. The water passages in the heads were enlarged. The gaskets were redesigned to promote better flow. Steam vents at the back of the heads eliminated hot spots. This attention to cooling is what allowed 10.8.1 compression on 92-octane fuel. Try that with a traditional cooling system, and you'd be dealing with detonation all day long. Now, the oil system was equally sophisticated. A windage tray kept oil from getting whipped up by the spinning crank. A crank scraper actively removed oil from the counterweights, reducing parasitic drag. The oil pan had internal baffles to prevent starvation during hard cornering. These weren't sexy features that made headlines, but they're what allowed the LT4 to survive on racetracks where lesser engines would have failed. Now let's address the elephant in the room. Only 6 368 LT4 engines were built. Total, ever. That's it. When you consider that GM built millions of small blocks over the years, that number is almost incomprehensible. The LT4 was hand-assembled at GM's powertrain facility in Flint, Michigan. Each engine was built by a small team of specialists. They weren't just bolting parts together, they were blueprinting each engine, ensuring every clearance was perfect, every torque spec exact. The limited production was intentional. GM knew the LT4 was expensive to build. All those special parts, the heads, the cam, the intake, added cost. The hand assembly added more. This was never meant to be a volume engine. It was a statement, a proof of concept, a middle finger to everyone who said pushrods were dead. The development process for the LT4 was fascinating. GM's engineers spent thousands of hours on the dyno testing different combinations. They tried wilder cams that made more peak power but killed low-end torque. They tested different compression ratios, finding that 10.8.1 was the sweet spot for 92-octane fuel. They experimented with different intake designs, ultimately choosing the one that provided the best average power, not just the highest peak number. The valve train development alone took months. The engineers had to balance aggressive cam profiles with valve train stability. Too aggressive, and the valves would float at high RPM. Too conservative, and they'd leave power on the table. The solution was those massive valve springs and strengthened rocker arms. But even then, they had to carefully match the components. The wrong combination of cam, springs, and rockers would eat itself alive in a few thousand miles. And endurability testing was brutal. Engines ran wide-open throttle for hours at a time. They were thermal cycled from 40 degrees to 250 degrees repeatedly. They were over-revved to find the failure point. One test involved running the engine at peak power for 200 hours straight. That's more than a week of continuous full-throttle operation. The LT4 passed every test. The sound of an LT4 was distinctive. It had that classic small block rumble at idle, but with a sharper edge thanks to the aggressive cam. At full throttle, it screamed to 6,500 RPM with an intensity that overhead cam engines couldn't match. The mechanical symphony of push rods, rockers, and valves created a visceral connection between driver and machine. You could feel the engine working through the pedals, the steering wheel, the seat. It was mechanical in the best possible way. And then racing proved the LT4's worth. In SCCA World Challenge, LT4-powered Corvettes dominated. The engine's broad power band and bulletproof reliability made it perfect for endurance racing. Privateer teams found they could run entire seasons without rebuilding, something that couldn't be said for the high-strung overhead cam competition. The LT4 might not have had the highest specific output, but it won races, and that's what mattered. The collector market has validated the LT4's significance. Grand Sports now trade for twice what regular C4 Corvettes bring. LT4-powered Camaros and Firebirds command serious premiums. But the real tell is the engine itself. Pull out LT4s, complete engines removed from wrecked cars, sell for $15,000 to $20,000. That's more than many complete cars cost. Collectors understand what GM built here, the ultimate expression of traditional American V8 engineering and ascent, and the LT4's influence extended far beyond its brief production run. The lessons learned, particularly about head flow and cam design, informed the development of the LS series engines that followed. The LS1 that debuted in the 1997 Corvette made 345 horsepower, but it was a completely new architecture. The LT4 was the bridge between old and new, proving that pushrod engines had a future while GM developed their next-generation design. And let's talk about what the LT4 meant for Chevrolet's image. Through the 1980s and early 1990s, Chevy performance had been in decline. The Crossfire injection Corvette of 1982 made 200 horsepower. The L98 of the late 1980s made 245. Progress was slow. The LT1 brought them to 300. But the LT4 showed that Chevrolet could still build a world-class performance engine. It restored faith in the bow tie brand among enthusiasts who'd been defecting to Ford and the imports. The timing of the LT4 was crucial. It arrived just as the horsepower wars were heating up again. After nearly 2 decades of decline following the insurance and emissions crackdowns of the early 1970s, performance was finally becoming a selling point again. The LT4 proved GM was ready to fight. It might have been the last of the old guard, but it went out swinging. Consider the packaging advantages of the LT4. A dual overhead cam V8 with similar displacement would be significantly wider and taller. The LT4 fit in the same space as any small block Chevy dating back to 1955. This meant it could be swapped into virtually anything: classic Chevelle, Camaros, trucks. The LT4 would fit where overhead cam engines couldn't. This compatibility with decades of vehicles gave it an advantage no modern engine could match. The LT4 program also demonstrated GM's manufacturing flexibility. Despite being hand-assembled and limited production, GM managed to build these engines profitably. They used existing tooling where possible, only investing in new equipment where absolutely necessary. This lean approach to specialty engine production would become a template for future limited edition power plants. The human story behind the LT4 is worth telling. The engineers who developed it were mostly old-school GM guys who'd grown up with small blocks. They knew every trick, every weakness, every opportunity for improvement. John Juriga, the chief engineer, had been with GM since the 1960s. He'd seen overhead cams come and go as the supposed future of performance. He knew that execution mattered more than architecture. The assembly team in Flint took enormous pride in building LT4s. These weren't just another engine coming down the line. Each builder knew they were creating something special. Many of them were hot rodders themselves who understood what this engine represented. There are stories of builders leaving notes in the valley under the intake manifold, signatures of sorts for future generations to find. The end of LT4 production in 1997 was bittersweet. Everyone knew the LS1 was coming and that it would be superior in every measurable way. But the LT4 represented the end of an era, the last development of the original small block architecture. It was like watching the final flight of the SR-71 Blackbird or the last voyage of a battleship. Progress demanded its retirement, but that didn't make it any easier to say goodbye. The technical legacy of the LT4 lives on in unexpected ways. The roller cam technology pioneered in this engine became standard across GM's lineup. The computational fluid dynamics used to develop the heads and intake became standard practice. The reverse flow cooling system influenced designs at other manufacturers. Even competitors admitted, sometimes grudgingly, that GM had extracted remarkable performance from ancient technology. The aftermarket support for the LT4 remained strong nearly 3 decades later. Companies like AFR, Brodix, and Dart still make heads specifically for LT4 builds. Cam manufacturers offer dozens of profiles optimized for the LT4's architecture. The knowledge base for modifying these engines is encyclopedic. Want to make 500 naturally aspirated horsepower? There are proven recipes. Want to add a supercharger for 700? That's been done too. The philosophical question the LT4 raised still resonates. Is complexity always better? The overhead cam advocates argued that 4 valves per cylinder and dual cams were inherently superior. The LT4 proved that wasn't necessarily true. A well-optimized 2-valve pushrod engine could match or beat the complex alternatives while being simpler to build, maintain, and modify. It was a victory for the principle of refined simplicity over complexity for its own sake. When the LT4 also represented something important about American engineering philosophy. While other countries pursued high specific output as a badge of honor, America focused on total performance. The LT4 might have only made 58 horsepower per liter, but it made those horses everywhere in the rev range. It was reliable at that output. It was responsive to modifications. It fit in existing vehicles. These practical advantages mattered more than bragging rights about horsepower per liter. Consider the cost equation. A dual overhead cam V8 with similar performance would have cost GM billions to develop from scratch. New tooling, new assembly lines, new training for technicians. The LT4 was developed for a fraction of that cost by optimizing existing architecture. This efficient use of resources allowed GM to invest in the truly revolutionary LS series while still delivering a competitive engine in the interim. The rarity of the LT4 has created an interesting phenomenon in the collector community. Because so few were built, many enthusiasts have created Hedgehost tribute LT4s using LT1 cores and aftermarket parts. These clone engines often perform identically to factory LT4s, but lack the matching numbers that collectors prize. This has created a two-tier market. Original LT4s command top dollar, while clones offer the performance at a lower price. The sound of an LT4 at full throttle remains one of the great automotive experiences. It's different from the LS engines that followed, rawer, more mechanical, more connected. You can hear the valve train working, feel the harmonics through the chassis. Modern engines are more refined, but refinement wasn't the point. The LT4 was about the pure, visceral experience of a high-performance pushrod V8 at the peak of its development. The LT4's brief production run makes every surviving example significant. These weren't just engines, they were the culmination of 40 years of small block development. Each one represents countless hours of engineering, testing, and refinement. When you see a Grand Sport or SS Camaro with its original LT4, you're looking at a piece of automotive history, a snapshot of American performance engineering at a crossroads. We look back nearly 30 years later, the LT4's achievement becomes even more impressive. It competed successfully against engines with twice the complexity. It proved that there was still innovation possible within traditional architectures. It showed that American engineers could optimize and refine just as well as they could revolutionize. The LT4 didn't try to be something it wasn't. It was a pushrod V8, unapologetically and gloriously so. In 2010, the engine's influence on GM's performance division culture was profound. It showed that small teams of dedicated engineers could create something special. It proved that hand assembly and attention to detail mattered. It demonstrated that limited production specialty engines could be profitable and image-enhancing. These lessons influenced everything from the later LS7 and LS9 engines to the current LT5 in the C8, Corvette ZR11.1 Think about what the LT4 represented to the technicians who worked on them. Here was an engine that any competent mechanic could understand and service. No variable valve timing to diagnose, no complex chains driving overhead cams, just push rods, rockers, and springs. But optimized to such a degree that it could run with anything from Europe or Japan. It was accessibility without compromise. The LT4 program also validated GM's decision to stick with push rods when everyone said they were crazy. While Ford spent billions developing their modular engine family, GM refined what they had and invested the savings in the next generation. The LS series that followed would dominate American performance for the next 2 decades, and it was built on the foundation the LT4 proved was still solid. Grandschwen, the cultural impact of the LT4 extends beyond just performance metrics. It became a symbol of American defiance against conventional wisdom. When the world said complexity was the only path to performance, Detroit answered with optimized simplicity. It was a very American response, practical, effective, and slightly rebellious. The LT4 didn't follow trends, it challenged them. And in the end, the LT4 was more than just an engine. It was a statement about the validity of traditional American engineering. It was proof that evolution could match revolution. It was evidence that sometimes the old ways, properly refined, could still compete with the new. The fact that only 6,268 were built makes each one a rolling piece of history, a testament to what's possible when engineers are given the freedom to perfect rather than replace. And today, when electric motors threaten to make all internal combustion engines obsolete, the LT4 stands as a reminder of what we're losing. The mechanical symphony, the visceral connection, the ability to modify and improve, these things matter beyond mere transportation. The LT4 represented the peak of accessible performance, an engine that anyone could understand but few could fully master. What do you think about the LT4's place in automotive history? Was it the last gasp of old technology or proof that simple done right beats complex done wrong? Let me know in the comments below, and if you enjoyed this deep dive into one of GM's most significant engines, hit that subscribe button for more stories of engineering excellence and automotive innovation. Thanks for watching, and I'll see you in the next one.